Okay, so we're recording this one for PLC implementation for stepper motor operation. So a stepper motor would basically have some inputs para dun sa ano natin. So if you're using a TB 6600 driver, you basically need an enable, which is our on in this case. You basically need a direction pin, which is our DIR pin. And you basically also need a clock. So in this case, there's no physical uh, button for the clock except a output that we have. Okay, so clock lang siya. Okay, so sorry, clock lang siya. So the implementation for this one is actually pretty simple, pretty straightforward. If you push on the ENA on button, you press it, it basically operates the enable switch to turn on. Therefore, that on the TB6600, you should be able to operate the device if this would be the case. The direction orientation is usually 0 is clockwise, 1 is counterclockwise. Okay. So the clock itself is just a set of two timer pulses or timing pulses that we have here, which have this is for purpose of being able to see it. Okay. Kaya siya ganyan. Okay. So let's uh, remove the annotation. Okay. So in order to be able to see it, we have the item set to 1 second. But again, uh, TB 6600, I think, has a minimum of 5 microseconds lang. Okay, so it's very, very small as a on period and off period. So you can always change this one to 1 millisecond rather than 1 second. But for visualization purposes, we're kind of sticking with this approach. Okay. So we do a compile action here. Okay. Take note we have the stop button. So if the stop button is put into a condition where we have it set to an open position, we won't have a value coming out of that one. Okay, so let's first insert stop, naka false, enable, direction, and then we have the enable out, direction out, and clock pulse natin. Okay, let's change the item to true and let's enable the system. So if this would be the case, since the stop, you see the stop in all the rungs that we have, basically this won't function. So it has to be on the false or open position in order to be something that we can end up using. So you can now see here that the clock is actually working. So if we put enable to a false condition or an open condition instead of a closed condition, you can see the clock is actually stopping. Okay. So direction is also the other side. Pagdating dito. Okay. Sorry. Direction can be set to 2. And you can see the direction output that we have is set to 2. But again, if this one goes to a false condition, okay, sorry, cancel, enable muna natin. So let's enable it first. So you can see that action there and then we disable this one, put in the stop, everything stops. Even the direction goes to a false condition. Okay. So let's stop the operation and let's adjust the time. So again, when you're dealing with smaller time periods, we recommend using milliseconds rather than micro. Although I think if you're using a Uno, which is an Atmel uh, 428A microprocessor inside, or microcontroller inside, or an Atmel 32, which is a Mega, you can actually support far more smaller time intervals. Okay. But again, we're sticking with 1 millisecond since it's a reasonable amount. So let's turn it all on, enable on, token natin yung value. You can see the clock pulse is continuously pulsing. Okay. So you would see this one. So the clock pulse itself can be controlled, and the clock pulse can also be counted. Okay. So that's that. So this is basically an implementation of a control circuit for a stepper motor. So stop recording now.